My name is Chris Bowles. I work at the University of Texas at Austin. I'm in the central IT group. And I was going to focus today on using Puppet Enterprise as a way to provide. Oh, like this. All right, this is better. As a way to use Puppet Enterprise as a way to provide Puppet as a service. And so the question is, Puppet for everybody, right? And everybody? Absolutely. You know, all of these people have a vested interest in configuration management, from development folks, operations staff, and even management, working together for victory. But all of these people also have their own expertise, right? There's kind of a continuum, anywhere from novice, where you can look at reports, use the Puppet Enterprise console, set variables, up to actually configuring hierarchy. And these are fairly complex variables in hierarchy. And then at the expert level, the sky's the limit. You could be writing your own code, writing your own resources, providers. And so we wanted to make sure at UT that we encompassed all of this, but we're able to provide it as a centralized service that people could basically plug into. And so this is based on a careful evaluation of Puppet Enterprise. We looked at a lot of different things, and we really liked what they provided. We thought that they had, that they really provided an excellent base to build on, but we needed a little bit extra. And so we kind of built the other three triangles. And so I'll talk about these, but basically it was a UT Puppet API, which are standards and culture about using Puppet, code and data federation, which you can see all of it, and then hierarchical configuration. So taking that one at a time. Basically, above everything else, we wanted it to be centrally managed and maintained. We wanted Puppet to be something that you could just click into. Rather than having multiple different Puppet servers, you would have one central place to point your servers to. And then so the database group, the web group, or any group could basically just point to your service and then get a configured server. So, good stuff. And then the standard Puppet API, it's kind of a loose API. It's a way of just kind of thinking like Puppet. So a lot of it, there's a cloud up there, so a lot of it's a shared culture idea. So a way of thinking at configuration management in general, but also specifically thinking about configuration management in terms of a model that's declarative rather than a bunch of procedures. So that's really pulled away from the specifics of implementing it. But the other parts of it, and this is more strictly the API, was that we kind of made a promise to our users that if you take a class and then feed it a variable, and then we split the variables, and we say console variables are for strings, for simple variables, and the higher variables are for complex variables. They're for arrays or hashes, which we'll talk about later. If you feed those into the console, you'll get a configured server. And then there's a fairly standard way in which we construct our variables and in which we provide classes and the variables. And we also wanted to be able to provide configurations hierarchically. So a lot of times when you see Puppet Enterprise presented, you see that even here, you see this fairly flat setup. You have a bunch of nodes, you have a bunch of groups, and you apply the nodes to the groups that you want, and it's kind of a one-to-one thing. We wanted to be able to do this in a more of a hierarchical way. To say that we have certain classes and variables that we want for our enterprise, but then our business groups, we want them to be able to add their own, but not to have to redefine that. And so the ideal being that if you see in this shared, in this kind of the colored in area, is that you get to capture the business logic, and that's basically what we're trying to capture. Is that this isn't necessarily the things that you can programmatically find out. This is more like the SSH port or anything else that you need to define yourself. And then so the ideal, as you can see at the bottom there, is that you take your node, your server, or servers, or however many you have, and you plug it into Puppet Enterprise, into this existing structure, and you get exactly what you want without having to do anything else, which is cool. The other bit was that we wanted people to be able to control and have command and control over the appropriate resources, right? We wanted to have, like I said, we're a central service, right? So you get certain basic things from being in UT Puppet, right? You get SSH, you get NTP. A lot of the stuff that you've seen here, we set up with a certain API. But we also want you, and so that's kind of the federal level. So from our DC office, we set all that. But we also wanted the individual organizations, and this is very specific to your group. This could be departments, this could be any way that it's useful to cut up your organization is that you can do this, basically. So let's say, let's call that the state level. And so what you end up getting, and this is basically Puppet as a service at UT, kind of how it breaks in at this point. And really, we've very much been focused on the base level, right? Because that's our first mandate, is to provide a secure, standardized, and configurable OS that people can add on to. And then but then also to allow people to build onto that at the, what we call the service level or the application level. Because we're basically, our group are the sysadmins, so we're at the base level. But then we also have service admins above us, and then they can support applications such as code or content. So what you end up getting is you get building blocks, and we'll talk about some of those. Okay. So to dig into some of the building blocks, the Puppet console, as we've seen, is made up of you have classes, which is the code, right? Then you have variables, which you can also pass in via the console. Those can be combined into groups, right? So in this instance, the database group. And then all of that can be combined to the node level. So those are kind of the building blocks that we have to play with. That variable, I'm showing a simple variable, so that's an ENC variable, but I will show a usage of Pirate a little bit later. And so the secret sauce, at least at the console level, is nesting, as you can see. And so you inherit, groups can inherit or can pass down classes, and they can pass on variables. You're slightly different though. Class inheritance is immutable. So if you're using a Puppet console, then you can assign, let's say at the base group, you can assign SSH, and then any group that is a child, because you can nest groups as deep as you want, will inherit that SSH and then can assign its own classes. And any node that's a member will get everything that's been assigned at the entire level. Now the only thing is, since it is immutable, you get everything that's been assigned at the entire stack. So you have to be kind of careful about how you set your defaults. Now with variables are slightly different in that you get the complete list, but then the child actually wins if there's a conflict, which is actually kind of useful in this case. So let's say as a base that you want your SSH to be configured, but you also want the listen port to be the default to 22. Okay, fair enough. And so then groups can attach underneath you, and these spook groups are basically subdivisions or other sub-organizations, and they can change that, and any node underneath them will inherit from them that SSH listen port, which is handy, since it gives them, since you make sure that they are getting SSH, they're able to change whatever you've coded to be changing, which is handy. So taking those building blocks, we'll put that together and see what that looks like. And so this is basically that example all put together. And so you can take your base group, you apply your SSH and your default port, and then your database can then add on another class, and then can modify that listen port, and then at the end, you get a server that's configured with both classes and the new variable. Now this is a very simple example, but it's actually a very powerful tool for allowing control at these sublevels. sorry, it's a multi-part slide. All right, so classes are additive variables, closest to the Doug wins. And this is what, if you actually, this is a screenshot. I don't know if it's big enough to see from the back, but this is what all that looks like when you actually look at the console. And so here's the SSH port overriding, and then you can see the, boy, it is really small. You can see where it's getting the value 2222 from the DB group. And this is actually the group, the list of all the groups at the bottom left that the node belongs to. And the hierarchy is difficult to see in the Puppet console. It is kind of implied here, but I'll show you later where we actually use a naming scheme to kind of make this a little more easy to understand and to kind of see it better. So it'll basically alphabetize it. And it's really small, but you can see the classes. And you can see where it's gotten the MySQL class from the DB group and the SSH class from the all group. So it's a useful tool. So if you, so that's the mechanics of it. But here's how you go about building a hierarchy in the console. And so basically, this should match your organization, whatever that means to you. I think the rule of 3 is useful here, where you have a top or a broad, generally applicable configurations, where you have some group, some large, group within that, and then perhaps a subgroup. And of course, you can have as many as you want. And each one is nested within the other, like the Russian nesting dolls. Now, the trick here is that this is what you create, this is what you intend, and this is what Puppet's going to show you. Puppet's going to give you the list of groups in alphabetical order. And so what we ended up doing was we created prefixes to kind of break these apart, and it'll give them to you alphabetically. And so it won't show you the hierarchy in maybe in a useful way, but you can kind of apply that. You can still use it in a hierarchical manner. And so a little bit more about console variables. And so as we've seen, if you take a class and add a console variable to it, you get a completed configuration. Now, that's not necessarily out of the box. Out of the box, you have to, as we've seen, you have to parameterize the class to get the variable that you're looking for. And so there's a little bit of kind of back-end magic you have to do at the code level. And this is kind of goes back to the API. This is kind of a standard that we've developed and, well, or blatantly stolen from somebody else. And so basically, just a little bit of code here. In whatever module you're interested in, there's going to be an init PP and hopefully a params PP. Now the init, as we've seen, is the default, and everybody's going to have that. And the params is, as kind of a good standard, is where you put your parameters, or the defaults for your parameters. I think that's the current coding standard. And so what we do here is that we set the class, and then right after the params, you set that variable. So in this case, it's the same one we've been using. It's the SSH listen port. So we set listen port equal to, and this bucket stuff here is basically namespacing this module. And so you say this SSH or PPC of SSH, which I'll get to in a sec. And then the params class, and then the listen port variable. And then you have the entire class inherits that class to make sure that the params wins. And then within the params, this is just a line within it that is kind of a stanza, really, that's setting listen port equal to that variable. Now, if you see, it's a $sign or buck, colon, and then the name of the variable. And what that does is that sets that variable equal to that top level variable. And that's actually when you set a variable in the console, you're setting a top level variable. And this is the way to use it, basically. And just as an aside, another part of our API is that we namespace our variables. And so you actually see where it's the name of the module underscore the name of the variable. So it's kind of obvious what that variable is intended for. And then you have a selector, which is the question mark. And then if it's set to undef, that means it's not set, then it actually sets it to unset, which we use. Or you can set it to 22 if you wanted to make that obvious. And then the default then gets set to that top level variable. So it's kind of a long way to say that this is how you use top level variables in a module. Okay, so one more thing. Now we've talked about console variables, but that's really limited to simple variables. You're not going to be able to do an array or anything more interesting, or a hash in a console. So we have to go a little bit deeper and actually get into the code level. But I would note, everything that we've done up until now is intended to be exposed to that kind of left side of the continuum. It's supposed to be easy to use. It's supposed to be set via the Puppet console, so it doesn't require coding. So Hiera, as we've seen, and if you're familiar with Hiera, is basically complex variables, although it can be used for simple, but that's our standard. And it's either arrays, like a bucket list, or it's a hash. And a hash, if you're not familiar, is just a bunch of key value pairs. And you can, it's turtles all the way down. You can make it very deep if you like. And this may look familiar. You can build the same hierarchical structure using Hiera that we did via the console variables. And that's very deliberate. They actually are intended to mirror each other. One way of saying it is that the console variables are the bit of the iceberg above the water, and this is a bit below. And so these should be structured in whatever way is useful to you, in whatever kind of hierarchy is useful for you to build for your organization. Now, the key to Hiera is Hiera is a directory-based creature, right? Or it's a file-based creature. And so we create hierarchies using directories, directory hierarchies, naturally enough. And so what we do here is this is all based in, if you're familiar with Hiera, it's all in the, usually the Etsy, Puppet Labs, Puppet, Hiera data directory. So all these are rooted at the Hiera data. And so at the very top, if there's no variable, you're going to go there. And this is all controlled via the Hiera.yaml, which I'll show you in a minute. And if you have a group, then that's going to be based on the console variable group, or whatever you decide actually. And then that could be a directory, and you can have your common.yaml file within that. And then if you have a subgroup, a group underneath that group, then you can put that as another directory underneath that, mapped via a console variable. And then you see that it flows from basically from very broad configs to very specific configs. And so in the same way that we can do it in the console, we can do it in Hiera. And Hiera.yaml is really where the rubber meets the road. This is where you're defining this. So in the same way in the Puppet console, we were using nested node groups to do this. In Hiera, you're using these divisions of the Hiera.yaml. And it's basically, you build it in a totally different way. In the node group, you're building from broad to specific, right? At the very top is your broad configs. And underneath that, you attach your groups and then your subgroups. In Hiera.yaml, you flip that on its head. And you start with the most specific. And this is actually exactly what you put in there. You put, it uses variables, it uses these factor variables essentially, and you set, so for the subgroup, it's group, sub, and then common. And then that'll read out to essentially be that directory in common.yaml. And then the next would be group, which is the same thing, just the common.yaml of the group, and then the common for all of it. And you can actually use all three, which we'll see in just a moment. And so this is just a graph that shows how these relate to each other. And so that there's a one-to-one mapping between your console groups and between your Hiera, which is very useful because then you can actually set these variables in the Puppet console, so you don't really have to think about it. So for the base is what anybody who attaches to the Puppet server is going to get, right? So if you set something at that level and somebody attaches to you, that's what they get. So they're going to get, let's say, NTP servers. They're going to get SSH port 22. That's real basic defaults. And then for the subgroups, that's actually set in whatever that group is in the console. And so that when a node attaches to that, they actually get that, which I'll show you in a second. And then that would point them to the foo subdirectory, and then whatever hierarchy is in there. And then the same thing for bar. Bar is a subgroup of foo, and so it's going to be the foo bar directory structure. So this is basically this all put together. And there's a kind of an important note here, is that all of this only really matters once it hits the node, which is similar to how you would usually test it. Like when you do a Puppet agent test, it's at the node level. That's where your config is coming from. This kind of gives you the same thing. So it's at the point where your node attaches into your Puppet Enterprise console. And let's say here, in this case, you have a base group, that's your default group. The DB is a child of the base group. MySQL is a child of the DB group. And so when you have a MySQL node, you attach it just to the MySQL group, and it's going to inherit all of that. And so that actually works for both ENC groups and for hierarchy. And then it's actually going to inherit all the variables along the way, too. And really, these variables are just normal variables. There's nothing really special about it. It's just that we happen to be using them in the hierarchy backend to point to specific data stores. And so in this case, MySQL gets sorry, that's a typo. Group equals DB, and the sub equals MySQL, which is going to point it to all three of those. And so the way hierarchy works is you get basically a search path. And so that you get a chance to set configurations at all three of those levels, which is useful. Now, I guess at this point, and I think I may talk about this later, but I guess you'd have to consider why would you want to do that? Why would that be important? And the reason being is that you can, depending on how you want to do it, you can pull those from different sources, which is what we do. Or you could actually give permissions to those different groups. And so that like only the broad sysadmin folks or the core folks could have access to write at that root level. Only the database admins could have access to write at the database level. And only the MySQL folks could have access to write at that level. So it lets you federate your hierarchy. The same ACLs don't quite, depending on how the role-based ACLs work with the new version of Puppet Enterprise, but there's a little more trust on the console side. But it's federating as far as writing the data, but it's also useful in terms of not having all your eggs in one basket, not having all of your hierarchy configs in a single file, which can be engaging. But one other thing about hierarchy is that this is one way of using hierarchy. It's kind of a search base and a way of separating configs and kind of fanning them out. But you can also use hierarchy in a slightly more advanced way, which is really handy for a lot of things, which solves that +1 problem. That problem where the data you have in common, you don't want to override it. It's what you need, but it's just not quite. You need like one more thing, like a firewall, or you love the default suitors, but you need to add one person to it. And so I won't get too much into it, but this is a good case for the hierarchy hash and the hierarchy array function, both of which will actually, you give it a key, and it'll add data to that key for each level of the hierarchy path, which is really handy. And we actually use this in quite a few modules. So almost lastly, there's also the code data federation part. And so we use source control very extensively at PT. And then we actually pull in all of our code and our data being hierarchy from different sources. And right now we use PCS repo for that, although we're moving to RTK soon, hopefully. And this is basically how we do it. And this is a bit of the secret sauce on the code side. Is that we break the Puppet.com module path into multiple segments. Each segment is independently pulled from a particular repo. And so this way, we can code at the base level the modules we need to. And the groups and subgroups can also code their own modules. without having to go through us. Is that this kind of federates access to being able to code their own things, which has been handy. And like I said, we're using VCS repo for that now, but I think that we're going to, which is kind of a poll topology that runs on the server and then does an SVN update. But I think RTK is a little bit more flexible. And this is the data federation, and it works in exactly the same way. I could just change the names on the slide. Is that we pull our common things from a base repo, the group entries from a group repo, and then subgroup from the subgroup repos. Same kind of idea. Now, the one thing that certainly occurred to us is that we're putting all of our modules in the same module path. So what if we name them the same? And that isn't bad. And so what we ended up doing, following kind of the standard Puppet Forge approach, is that we actually namespace our classes. So our standard is that if you create a class, you give it the prefix of your group, basically. So we're the PPCM group, provisioning, patching, configuration management, and monitoring. And so all of our stuff is PPCM underscore something. And so that's a handy way of doing it, as a way of kind of separating out. So if you see that class, you know where it came from. Okay, so that's pretty much it for our existing stuff. And let me give you a little peek into the future and we can take some questions. And so right now we're working off of these kind of mammoth repos, right? So that if I change one thing within the core repo, like if I change our suitors module or SSH module, VCS repo is going to see that. It's going to update the whole thing. It takes a while. It's kind of slow, but it also is a pull methodology. So we're actually going to move to a little bit of a leaner, more agile approach. But using each module will be its own Git repo, which I think is a better way of doing it. It's a better kind of software production kind of standpoint. Now the cool thing is we're actually using Atlassian's Git Essentials product. I think we're going to be trying it out. Is that they actually have branch-based ACLs. And so we'll be able to set a head branch as a production branch, but then non-production branches can be created on the fly, whenever, not a problem. So it'll help get more collaboration for our core stuff. It will help kind of cross-pollinate, which will be very handy. The other thing is, like I said, our R10K. So now that we've broken all of our stuff up into Git repos, you can use R10K to push those into a Puppet server, which is, if you guys haven't checked out R10K, I would seriously Google it. It's really, really good. It's a way of doing push deployments. You can integrate it in with Jenkins, continuous integration, very good stuff. The other thing that's kind of neat that we're looking at is having Puppet environments defined by code. And I guess we saw that they were using Puppet environments in one of the previous talks to deployment-based environment. And we actually use Puppet environments strictly as a way of testing Puppet code. And being able to define that on the fly, basically, from disparate Git Git repos is a real good win. Because right now ours are just basically SVN branches, which is not nearly as agile. And then, of course, automated testing. We're very much into the RSpec, Puppet Lens, and all very good stuff. And I highly recommend learning about RSpec. It's a great way of testing your stuff. Okay, so yeah, that's all right. So I guess the takeaways for this is that you can, well, Puppet Enterprise is great. I mean, we think a lot about it. But then you can build on it if it meets your business case to have hierarchical kind of federated control. If it makes sense to get more people with their hands on the levers of Puppet Enterprise. This is a good way of doing it. I think nesting the node groups is a good way of doing it. Having smaller bits of hierarchy rather than just the default kind of places. Building a kind of a customized hierarchy is good, and you can use that to provide essentially Puppet as a service to your group. give them the ability to use it themselves, to code their modules and add variables to the modules. Using the hierarchy configs, using building blocks, allowing plug and play as needed, and then empowering users at all levels to develop it, which is good stuff. Yes, any questions? Sir?
So, I have a few questions. The first one is, what kind of scaling issues do you have? Do you have so many, I imagine you have tons of
The gentleman asked about scaling issues. It's not too bad actually. We're maybe at that sweet spot where we have we got maybe a dozen. We break down into we have a common group, we have our department, we have our management level. So we have different sysadmins responsible for different departments. The departments and then the services. There's a little bit of work involved in building the structure, but beyond that, it gives you a kind of a framework to hang your configurations on. And we did do that manually, but I think in retrospect, we could have used break tasks to automatically create groups. It's been a great way to sell public in a way to kind of bring people into the fold. Is that we say it's not just this mammoth, terrifying configuration management thing. It's their terrifying mammoth configuration thing, and so they get to have their service group that they just plug their nodes into it. It kind of as a metaphor seems to work pretty well. But yeah, no major scaling problems as of right now.
How many nodes do you place?
We're about 500. Now that being said, this is very dependent upon your use case. We tend to have lots of variability within our nodes. And so there's enough variability at the different layers. We don't really have like 1,000 the same thing. These are kind of, they require a lot of, not hands-on, but there's a lot of individual customization. But I see your point though. I mean, I think this is definitely not a one-size-fits-all. This is work for us. Any other questions?
I have one more.
Oh yeah. Yeah.
So you said you control your role
I'm sorry.
You control your roles, individual department roles with
Well, the role-based, we create the roles using hire.yaml. So that's how we go about it. Yeah, so we basically define our hierarchy. And it's funny, I should talk about this. The way that we enforce the ACLs is that only the right people have access to the repos. And I'll add that next time. That's a good one. Is that only the right people have access to write to the repos. And if they break something, they're going to break their own stuff.
In other words, EV has a repo, admin repo, or EV or marketing or whatever. Under each level is the same.
Well, honestly, it's the way that we do it, it's each group. There's basically repos at the group level.
Okay.
I just thought I should have three things. But yeah, no, you're right. The way that we do it is it's you have kind of a core, and then each group has their own. And I guess this is, and I'm not really sure how specific this is just to us. I think it's useful for us because we have broad configs, and then we have like one of our big sysadmin groups tends to use a different SSH point. And so that's true of all their stuff, and it's not really shared. There's no real reason that the groups that they manage have that other than that they manage them. And so this is just kind of our way of kind of incorporating that business logic in an easy to understand way in the console where it's very visible. Although almost all of this can be done via just hierarchy. And that is more kind of an infrastructure as code way of doing it. And I suspect that we'll get there. But it's in terms of getting people on, and getting people comfortable with the product. I think it's much easier if they see the variables, if they kind of see that RSOP, that resultant set of policy. So, thank you for the questions. Anything else? Still have 5 minutes. It's a long time.
Not necessarily a question, but just a comment. I think that you watch this from a sort of PS perspective, you see the same sort of stuff. People want better development, they want something to something, but not all things.
Yeah, it's,
Right, and where you're going is the same way you're going.
oh, cool. Well, that's always good to hear. And a lot of this has been, it's been a team effort, and we've been following the Puppet Labs lead as much as we can. And I'm looking forward to the role-based ACLs and the console. But yeah, and this has really kind of unlocked our ability to, we're no longer the gatekeepers for configuration management. We actually have some of the most active people in Puppet are members of a group. We have a web development. They built the whole stack using Puppet, and they're doing stuff that I'm amazed by. Because they're, and in fact, one really cool thing. I figure I got 5 more minutes, so I can show you something cool. Nice. One really cool thing about R10K, and there's a great blog entry that I wish I had put up on the slide. Maybe some of you Puppet folks might know what I'm talking about. There's a lot of good stuff on R10K. Robot 10,000, by the way, is what it means. But the great thing about R10K is that if we can define environments with code using R10K, that actually unlocks people's ability to basically set up their own custom environments, including Puppet Forge modules, which is very cool. And so they get to just basically drop a totally independent environment on the Puppet server, and then they test that. And they won't hurt anybody else, they're not going to touch anybody else. It's a very, it's cool. We're gonna try that out.
And that's where we kind of end up is that use RTK to deliver code that is group, you basically application cases, we call it controller code, that only includes metadata for that specific group and app. And it includes RTK and all of the modules that are required for that. And now we have another module which is used by everyone and referenced by other
Yeah, and I would definitely say that right now, I mean, we are fairly early in the adoption of Puppet Enterprise, and so we've just now completed our implementation. So we're just really been building that base, And so a lot of this is very much like, how do we get people to be able to change simple things, basic configurations. But certainly as we move forward, we're looking at doing more like roles and profiles and things like that, using RTK in interesting ways. But always with an eye towards more control, and as long as it's safe, as long as you're kind of, it's funny the way I originally said is that you can break your own stuff. As long as you don't break anybody else's, then we're happy. Anything else? Okay, well, thank you very much.